Good afternoon once again, everyone. Thank you so much for being here on time. Today, we're going to continue our discussion on data structure. So last time, we said that there are different types of data structures. We have vectors, lists, matrices, arrays, factors, data frames, and others. What's most important for us are data frames. And actually, there are others like time series, which we're going to discuss also in the future. Now, we learned last time that vectors are atomic. When we say atomic, they only have one type. Okay, so let me sweep first the elements here. Okay, and also this one. Okay. Vectors are atomic because they will contain only one type of one data type. So it's either they're all characters, all integers, all numeric, all complex, etc. So last time we had several examples of generating vectors, different types of vectors. One of which is we generated a vector of numerical figures, numerical values using R norm. We learned that when we generate R norm, when we use R norm as a function, it will give us a randomly generated numbers that are normally distributed. So the syntax is identify the number of observations, and then you have to define the mean and the standard deviation. If you don't define it, then it will be assumed to be mean is equal to 0 and standard deviation is equal to 1, which we defined as a normal standard normal distribution. Okay. So let's keep that and let me run this instead. So here we're setting that seed. Okay. And I'm creating this object devs1. You don't have to run this because we ran this already before. Okay, and maybe we we use different figures, but you may just observe it. Plus, and then if I generate this, okay, this will generate the 100 because it's in parentheses. Then it will generate the. Okay, I don't like to generate it. Let me just generate the first 6 figures. All right, here, if you want to follow along and insert that as a code chunk, you may do so, of course. So here, I'm using set.seed, and we know what this does. It makes possible for us to generate the same random numbers. Okay, if I run this, if you run it also, you'll get the same first six values, and of course the same 100 other values. And then if we get the mean, we expect it to be around 90. Okay, let's see, it's 90.14. Had we increased the size, the length, or the number of observations, then it would be very, very close to 90. Here, because it's only 100, there's some variance with it. And if you take a look at the standard deviation, it's 4.59, 4.6, quite far from 5. But I mentioned before that if we increase this, let's say we make it 10,000, and then we run this, and then I take the mean, so 89.98, so it's closer to 90 than the first example that we had. And the standard deviation, 4.96. A while ago, it was 4.59. So this is a lot closer to the standard deviation that we defined because of the greater number of observations. Okay, so let me just go back to this. So let me run this again. Okay, and then we learned about by the way, when we generate a vector, you will see that it will be under values here. It will be in the global environment and it will be part of values. And it's different when we generate a data frame, which I'm going to discuss later. because it will not form part of values, but rather data. I'll show you in one. Okay, so this, let's get the class. Let me get the class of devs. Okay, sorry. This should be devs one. Okay, by the way, if I get the summary, it will give us the 6-number summary or 5-number summary plus the mean. So that's the minimum and maximum, the first, second, and third quartile, okay, plus the mean. That will give us the summary. On the other hand, if we type structure, that's one, it will just give us a list. Okay, so again, sorry, that's one, structure. Okay, it will just tell us that it's numeric, it's a vector from 1 to 100, and these are the elements. Okay, so if we get the structure of a numeric vector, it will just identify the type of vector it is. It's numeric vector, and then on brackets it will tell us how many observations, and then it will print a sample of the observations of that data set. Okay, so that's the structure, and the class we know will give us numeric. All right. In the same manner, okay, so I think this is just the same. What's the difference between G and G1? Anyone, please? Can anyone tell me what's the difference between object G and G1? Is this the file that we did last time, class? My
Yes.
apology. Okay, good. So same on
So
G and yes.
if I'm not mistaken, but G is numerical, and then G1
Yes.
is integer.
How did you know? What's the difference?
Because of the way that the data points are written po.
Okay. Specifically, thank you, Stephen. You're correct. Specifically, yung the use of the colon. Okay, pag gumamit tayo ng colon, use the colon, then this will generate a vector of integers. So let's just try. Okay, so here we're having G printed and G1 also printed, and we're asking for the class of G and G1, type of G and G1, and then the length. Let's just include anyway G1, length of G1, and we know that it will be the same 10. Okay, let's run everything. All right, so the first print out is your G. Your next print out is G1. So they have the same elements. Their difference is in the class. G is numeric, which means G can take on decimal places, while on the other hand, the class of G1 is integer. The type of G is double, and double signifies that it refers to the byte size that is given to this object, double, which means that it will be provided with higher byte, a bigger byte as compared to the integer, because it has to accommodate decimal places. And the length, of course, of both is 10. Okay, and if we ask for the class, it's G is numeric, G1 is integer. But if you take a look at the values here, they will be both under values. G is numeric, G1 is integer, and both of them are vectors because they contain elements that have the same type, data type. So for G1, they're all integers. For G, they're all numeric. Okay. All right. Let me pause for a while. We okay so far? Yes. Understood. This one. Chat na lang yes, please. Okay. See you. See you. Please share your question to everybody. So may I request class, when you ask a question, please share it with everyone, because if I answer your question and the others don't know what the question is, then they will be lost. Okay? Okay, thank you for your responses. See you, kindly share your question to everyone. See you.
Sir, my email phone has
Yeah, just copy paste it, please, so that others can see.
yes, sir, I
Oh,
did
there,
that.
okay. All right. So this is the question of CU. Now let's see. May I? Okay. I guess I will have to. Let's see. CU. CU, could you kindly? This is a good opportunity for us to learn. Okay. See, I just make you co-host. Sige. Okay. And then let me stop share. CU, could you please share your screen? Okay. Object G could not be found. Could you run G again? Go to line 149. Okay. Control Enter. Run that, please. All right. There's your G already below. Okay. Okay. You can see here in your environment, you can see G there, numeric. Below, go to your environment, you can see the object G, right? Below.
Yes, sir.
Okay, did that answer your question? Okay, I suspect you were not able to run that a while ago.
Yes,
Okay.
I did work. I'll take
Okay,
it.
good. Thank you. Thank you. I appreciate really your questions, class. Please don't hesitate. Don't be ashamed to ask questions because everybody will learn from that. Okay. Now, as we said, vectors are atomic. They can be numeric. They can be integer vectors. How do we create integer vectors? We can create it by using the colon sign, for example, 1 to 10, that will generate a integer vector, or we can define it to be a 1L, 2L, 3L, etc. Okay, so I don't know if you have this, but if not, you can create your own code chunk and copy this. Okay, did we do this last time, class, or am I referring to the file of the other section? Can you chat, please, if this is the same code that we generated last time? Class, is it the same?
Sir, I don't
Yes?
think we have done this part yet.
Okay, sige. All right, so why don't you insert a code chunk? What's the shortcut for code chunk, plus? Control plus, yeah, for Alt plus I. This is for Windows. For Mac, it will be Command
Option I.
okay, Command Option I. Okay, so let's insert a code chunk and then kindly create this object K, where we're concatenating 1L, 2L, 3L, 4L, 5L, and then let's see what type or class and type is K. I'm going to run this. Okay, so K is, we know it will be printed because I place it in parentheses. K is 1, 2, 3, 4, 5. The class is integer, the type is integer. And you can see it will appear here in the values. Okay, what appears here in the values are vectors. That's one which we run a while ago is numeric, and then G is also numeric, G1 is numeric, K is numeric. These are vectors. All right, any questions for this one? Okay, you notice that I'm going through this quicker than how we did it last time, because this is just a review of the concept that we learned last time about vectors. All right, so let me move on. Okay, here I'm creating, you may wish to copy this also, just as an additional exercise. Here we're creating this object M. and we're concatenating 1, comma, we're specifying the elements here, and it's not 1, column 5, and we know that this is a numeric vector. Every time we specify the elements and not use 1, column 5, which generates an integer vector, this one, on the other hand, will generate a numeric vector. Okay, let me run this. Okay, let me run that, and then 1, 2, 3, 4, 5, numeric, and then the type of is double. Okay, this is numeric class. Can I coerce this into an integer? Can I create an object out of M, which is numeric, and coerce it as an integer? The answer is
No, sir.
no. Bakit? Numeric to, di ba? Tapos, i-coerce natin as an integer. What's the general coercion rule, class? Ano ba yung general coercion rule natin? Last time. Ito, di ba? Did we discuss yan? Did we discuss already the coercion rule? Class?
Yes, sir.
Di ba? Oo. So, yung coercion rule
The
natin,
rankings.
yeah, the ranking, yeah, it's here below pala. Logical, and then integer, and then numeric, and then complex, and then character. So, we know that we can coerce the lower ranking, like logical can be coerced into integer, and integer can be coerced into numeric. Okay? But numeric to integer, okay. Now, it used to be that numeric cannot be coerced into integer. Okay, however, I discovered something that there has been a change. There has been a change in how our coerces. So let's take a look at this. M is numeric, right? Now let's create an object called N, where we convert M into an integer. Okay, so let me run this. Let me run this tree and ask for the class and type of. Control Enter. There. Okay, na ano siya na it was converted, okay, or coerced to become an integer. So there are exceptions to that rule, the hierarchy. Like this one from numeric, there are certain instances when it can be converted into integer. Right, but the general rule is the coercion, implicit coercion, is from the least rank up to the highest rank, which is the character. Okay, any questions about that, class? Clear ba so far? Okay, may I request everyone to please participate when I ask questions. Thank you, Stephen. Okay, thank you. How about the others? Yeah, thank you. Okay, so keep it coming. I hope more than 90% of you respond to queries like that, because they're important for me. Number one, it tells me that you're still there, you're participating. Number two, it tells me that you understand what we're studying. Okay, and that you're not doing anything, any other thing, any other task aside from this one. Okay. All right. About this, did we work on this last time? We have here this object called let, and then we're creating this A, B, C, D, E. We ask the class and the type of, and can this be converted or coerced into an integer? Did we do this last time, class?
Yes, sir. We did this last time.
Okay, thank you. All right, so let me first run this first three. So here we have here let, right? It's a character vector, A, B, C, D, E, character. And then let's see if we can generate let one. Let one, we're converting let into an integer. Okay, Control Enter. All right, so notice that NA is introduced by coercion because the letters, okay, cannot be converted into an integer, okay? Because characters are higher rank compared to integers. So that's why we're getting a warning here that not applicable were introduced by coercion. So everything is NE. Okay, so that's a general rule. A higher rank data type cannot be converted into a lower rank. But a lower rank can be converted into a higher rank. Okay. All right. So let's skip this. I think we did this last time. Okay. All right. So I'm going to create this. Then good practice is sample. Okay, so this is wrong. We should have a. Do you have this code, class? Do you have this code?
Sir, wait lang po. Can I copy it?
Yeah, sure. Okay, so let's first learn what the sample function will give us. Okay, here I'm typing question mark and then sample. Yeah, just use tab for this. Control enter. Okay, so this will give us this from the help function of R. So the sample function comes from the base R, from the base, which is preloaded with R. So that's why we didn't need to. There was no need to install a package. Okay, no need to install a package and no need to require that package because the sample function comes from R, from base R. All right, so what does the sample function give us? Sample takes a sample of the specified size from the elements of X using either with or without replacement. Okay, so this is the syntax. Sample X. Okay, X is either a vector or one or more elements from which to choose, or a positive integer. So we can generate a sample from a set of, let's say, integers, positive integers. For example, let's define X to be from 1 to 100. Okay, sabihin, ano yung number sa bingo? Ano yung number doon, class? B-I-N-G. Yes. Anyway, I'm not sure. Hanggang 60 ba yun? Okay, we can use 1 up to 60, and then we will ask R to get a sample of those numbers. Okay, so that's what X refers to, this one. And then the size tells we're required to up to 75 pala. Thank you, Shelly. Okay, 15 each times 5. Yeah, B-I-N-G, that's 5, 15 each. For size, we have to identify what's the size? How many samples are we going to generate? And then here, replace is equal to true. Replace is equal to, so replace can be true or false. Replacement means, okay, let's assume you have a glass bowl of numbers. Let's say parang sa bigo, no? We have a a container that contains numbers 1 to 75. So if we draw out the first number, let's say we were able to draw out 21. Okay. Replace is equal to true means we return 21, so that it can be withdrawn again. So that's replace is equal to true. On the other hand, when we say replace is equal to false, once we draw out that number 21, we do not return it. Okay, we do not put it back into the glass bowl of numbers. That's what we mean by replace. Okay, so here below, let's just ignore the probability. Here below, okay, we have here examples. Okay, so all right, what's an example here? Okay, if you take a look at this here, the x is a vector of 0 and 1. Okay, 0 and 1, and then we're asked to generate 100, and then replace is equal to 2. Of course, we should return back either 0 or 1. This is a binomial trials because it will only generate 0 or 1. So let's have this example. A very easy example. Let's copy this and let's just run it in our console. So I'll run it here in our console. I copied it. All right, so here it's a sample. Okay, sample of what? Where will R get the sample? From either 0 or 1, and then how many observations? 100. And then replace is equal to 2 is important here. Because if you put replace is equal to false, it means once you draw out 0, then you cannot return 0 anymore, right? So that will leave you with 1. So if you draw another object, another number, then you will draw 1, right? So therefore, you will not have any number anymore. Well, let me just show that. Okay, so false. Replace is equal to false, which means that when you get a number, okay, since you only have two possible numbers, 0 and 1, then this will, let's see. All right, see, take a look at this. Error in the sample. Cannot take a small sample than the population when replace is equal to false. Okay, so you only have two samples, 0 and 1. You have only two data there. And then how can you possibly get 100 out of that? Okay, so that's why this is important. Okay, arrow up so that by the way, class, when you, for example, you want to go back to a particular code that you have written here, you cannot actually go back here in the console. You cannot click it and copy it. You cannot highlight it and copy it. The way to go about it is to use the arrow up and arrow down. See, I'm pressing arrow up, and it will lead me to the previous codes. Okay, and arrow down, back down, so that if you want to copy a particular code that you wrote in the console, you can just go. You can just on another new line, then just arrow up or the arrow. Okay, so let me copy this. The sample there. Okay, and then let me type replace is equal to true. Okay, so this will work now. So it will generate 100 numbers, and it will choose just between 0 and 1. Okay, so this is what we call a Bernoulli process. Why Bernoulli? You only have either true or false or 0 or 1. Those are your only two. So it's a binomial distribution. Okay, Control Enter. All right, so you have this. Okay, we'll have different results because we didn't use the set that's okay, but it's a vector of we didn't name this right? So let's call this v1. Okay, v1. So we created an object called v1. All right, and let me run this. Control Enter. Okay, so v1 is already here. v1, and you see this is numeric. This is numeric. It consists of 0 or 1. So this is numeric if I attempt to if I try to coerce this alt minus, okay, into as that logical, and then V1. Okay, what am I doing? I'm coercing my V1 to become logical, and I'm creating this object V2. If I run this, Control Enter, you notice that we have V2, okay, which is logical. Okay, true, okay, because it's converting. Okay, it replaced it replaced the V1 as logical. Okay, so in this case, this is another exception, as I said. Here we're able to coerce the we're able to coerce this numeric vector into a logical vector. Okay, so there are exceptions to the coercion which I stated a while ago. Okay, let me pause for a while. Is that clear, class? Is the rule on coercion clear? Generally, you can coerce a lower rank data into a higher rank, but not vice versa. But there are exceptions to that rule. Okay, thank you. Thank you for your responses. Okay, so let's go back here. Okay, let's create. If you copy this, okay, if you copy this, we're creating this object int using the sample function, and our x, our vector is int, where we'd like to generate 100, replace is equal to true. What happens when you run this?
Error.
Now, why error? Thank you. Who answered? Hello?
Sir, the object is not found.
Sorry?
The object is not found.
Okay, why is the object not found? Okay, let me see. Okay, I see your, so that I can see everybody. Why don't I see the other participants? Object int not found. Okay, thank you, Krisha. Yeah, you're correct. Object int not found. So here, Emil said we haven't input value. Yes, that's correct. So thank you, Krisha. Thank you, Emil. You're correct. We're using this sample function, and our x, our vector is ints, but we don't have an ints object here. If you check our values here, our vectors here, there's no ints. Okay, so let's first create that. So let's change the name. Let's just, because it's confusing, ints and ints. Let's call this just sum. Let's call it sum. Okay, let's call it sum, and then we have to create first this object of ints. Okay, so why don't we create ints to be, okay, to be, let's see, actually 1 to 100. Okay, 1 to 75, for example. So we're creating ints to be 1 from 1 up to 75. And then let's set that seed, let's set it to 999, sample only. Okay, so what's important is that we have the same number, and we created this object ints, and then we need this set that's it because we're doing this sample. So take note that sample will generate random numbers, and unless we use the set that's seed, we will generate different random numbers. Okay, so we want to create a sample with the object name sum of 100 values. It should be taken from 1 up to 75. Okay, so which means we're going to create objects, numbers from 1 to 75. There will be 100 observations, and there may be repetitions of the numbers, because replace is equal to true means we return the number when we draw it. Let's say we do 55, we can return it. We return it, so that means that 55, there's a possibility that 55 will also once again be withdrawn. All right, so drawn out. Okay, let's run this code chunk. All right. So if we check, okay, let's put here, let me delete this for clarification. Okay, if you check the head of sum, let's take the first 20, and let's run this. So did we get the same answers, class? 27, 68, 61. So if you run everything, if you run the same codes as set.seed, we should get the same 20 observation. Kindly confirm, class, if you got the same answer.
Yes, sir.
Okay, good. Thank you. Let me wait for the rest to give their responses. Okay, I have a few responses from the class. How about the others? I think there were only 6 or 7 who responded. I'm still waiting for the 14 who did not respond. Can you chat, please, if you got the same answer as mine? Okay, more than 50% have not responded, please. How about half of the class? I don't think half of the class has responded to my query. Are you able to follow this? Okay, use zero length. Okay, thank you, see you. May question dito si, si John Robert. Okay, I want John to paano ko ba nakalimutan ko, class? How do I make John share his screen? Kasi hindi ko na natanggal si CU dito. Once I made her co-host. Nawala na. John, sorry, I'm having difficulty finding here. Alam ko pwede yun.
Sa share screen po, sir, tas multiple participants po.
Share screen. Okay, share screen.
Yes po, sa Zoom po.
Yeah, share screen and sige, all participants na lang. Okay,
Yes po.
sige. All right. So, John, could you kindly share your screen, please? I'll stop sharing.
Sure, sir.
Okay, thank you.
So, parang ganyan po, sir, yung lumalabas.
Our sample.
Naka-white
Okay.
lang siya, so
Ano to, dots o backticks ba yan? Parang dots yung sa sa code siya. Parang dot siya, parang period siya. That should be backticks. At saka yung set.seed mo dapat dot. Set.seed. Yan, okay. Alright. Okay, that should work now. Pero yung mo, yung nasa dot ba yan? Or yung, ayan, okay na. Highlight mo lahat yan. Yan. Actually, pag irarun mo sa taas, huwag mo na i-highlight.
So, wala pa.
Tanggalin mo nga yung highlight. Okay.
Kasi ito, sir. Hindi siya
Oh,
na,
ano ba yan? Dot ba yan? O
yung ano po,
backtick?
sir.
Yung three figures yan. I-backspace mo nga. And then, dapat backticks yan. Backticks ba yan?
Yes po, sir.
Okay, kasi masyadong maliit, hindi ko makita. Huwag mo na i-highlight yan. Okay. Ba't mali pa rin? Sure ka na backticks to?
Yes po, sir.
Saan mo, from, mag-control shift, ano ka nga? Control shift I.
Ayun po,
Command,
sir.
command alt I, sige.
Yes.
Bakit, wait bakit hindi siya, tanggalin mo muna yung, tanggalin mo muna yan.
Ay.
Remove that first, sige. Okay. Wait. Yung sa baba, backtick yan.
Yes po, sir.
Okay, sige nga, below, control alt I. And then copy mo yung code. Yan. Control C, control V.
Ayun.
Okay. Ayan.
Ayun, sir.
Ano kaya
Magic.
tingnan nga natin bakit mali. Yung R
Pero dapat
sample
gagana
daw.
rin to sa baba, di ba?
Wait. Naka-double space ba yung sa sample?
Hindi po, sir.
Hindi naman, no? Ayan, mukhang umokay rin siya.
Yun pala.
Hindi lumalabas
Pero gumana-
yung ano eh.
Opo,
Yeah,
yung orange
pero
po.
ano kaya yung problema nito? Kasi tama naman yung ano mo eh. Tama naman yung you type it correctly. Can you go to line 217?
Po.
Line 217, yung may X dyan sa 217. Go to
Ay,
the
okay.
end.
Gumana na po ata, sir. Wait. Kulang lang nung, ito po. Wait. Sa line 212.
212.
Ayun, gumana na rin siya. Kasi kulang po na itong tapos dito.
Okay. So, which means that tumuloy pa rin siya dun sa next ano.
Yes po. Okay,
Okay.
po.
Alright, sige. Thank
Thank
you.
you po, sir.
Thank you, John. Okay, we appreciate questions like that, class, kasi you will encounter those difficulties. So it's important for us to learn how to learn how to address errors like that. You have to look at the message. You have to look at sometimes may space. You put spaces na dapat walang space because R is very specific or very particular about capitalization, punctuation, etc. Okay, thank you, John. Thank you for sharing your question.
Thank you rin po, sir.
Okay, all right. So this one, what did we do with this one? Well, we just because we're going to use this sample when we go to multiple linear regression. And remember, I told you before that we're going to, when we do multiple linear regression, we're not going to use all of the data. We're going to split your data into a training data set and a testing data set. To do that, we're going to use this sample function, okay? Because from here, you can see that we can split your data, okay? In fact, when we take a look at this, we're going to use this, the probability. Okay, but we'll do that next time. Okay, so how about character variables? If you take a look at this, we know that this will not run. Why will this code 180, line 180 not run? Anyone? Why will that not run? Class? Can anyone offer a suggestion why that one, we're creating an object and it's concatenating Monday, Tuesday, Wednesday, Thursday, Friday. if you try to run that, that will return an error error message. Why do you think that will return an error message without even running it, class? Any guess?
Sir,
Yes.
it lacks the two lines on top, like this compared to the second line, because
What
it's
lines?
a I forgot
What
what
do
you
you mean
call
by
it.
lines? Quotes.
At the quote, yeah, the quotes. It needs to have the quotes because these are character.
Okay, yeah, you're correct. Okay, I'm having a problem. I can't see the participants. When I made CU the co-host, hindi na naalis sa participants na. When I click participants, let me see. Invite what? No? When I click participants, I only see CU. This happened when I made CU as my co-host. I wonder why. This never happened to me before. Participants, I only see you. Okay, anyway. All right. So this one will not run because all characters should be in quotes. Okay. So this will run now. So we have this object I, and I is also a vector, a character vector. Okay, a character vector. And when we get either the class or the type of, we know that it will be character, and the length of I is 5. Okay. Now, what happens when we create a vector where we have different types? We're creating this object called X, and X consists of 1, numeric data, 5.4 is numeric, 2 is logical, and hello is character. Okay, so can we create this object? Yes, we can. So if I run X, okay, what happened? When I created X, what happened to X? You notice the output here, the printout. Okay, anyone tell me? Can anyone answer that question? What happened to X? What is now X? Can easily see see the answer to that question by looking at the environment and see what X is. What object is X now? Class?
Sir, it is now character indicated by the CHR
Yes,
on the
correct.
environment.
Yeah, thank you. You're correct. X is character. It's 1 to 4. Okay. And what happened to your numeric, your logical value? In the printout here, notice it has quotes. So this indicates that these are characters, right? Characters, yeah. That's correct. Thank you for answering, class. So what happened here? R did what we call, what did R do? What's the word for that, class? You know that word? Letter C, class? Okay. Some of you answered. Yeah, that's good. Correct. That's a coercion rule. Remember, the lower rank values will be coerced into the higher rank value. Okay, the higher rank here is character. So we were still able to generate this vector X, but it's not a mix of numerical, logical, and character. It's not a mix of them. It's still a vector. How do I know it's a vector? It's under the values. Okay? Under values. Let me just illustrate Remember what we did last time? Do you recall the diamonds data set? Did we have an example of the diamonds data set? Can you chat, please? Class, did we discuss the diamonds data set?
Yes, sir.
Yes, okay. Thank you. All right, let's once again access that data. So how do you access that data, class? Yeah, correct. It's the one with the carat. Yeah, Carlos. If we want to access that data, what do we need to do first? Can we view that, class? Let's see, view diamonds. Will we be able to view this object? Could you kindly try, please, class? Kindly chat yes or no.
Sir, object not found. You have to
Object not
generate it
found.
first po.
Yes, object not found. Why? Where is diamonds coming from? What package is this coming from? Anyone? Class, you recall? Okay, we have an answer here. Yeah, thank you, Emil. So this is coming from ggplot2. Did we install ggplot2 last time? Class, did we install ggplot2, the grammar of graphics package?
Yes, sir.
Yes, we did, right? Remember, install that package as ggplot2. So do we need still to install ggplot2 again? The answer is no. We don't need to install ggplot2 again because it's already installed. In fact, if I go to package and then type here gg, just maybe the first letters, gg, and we can see here already ggplot2. In your case, it's not checked. Okay. Excuse me, I bit my tongue. Sakit. In your case, it's not yet checked. Okay. So how can we use the functionalities of ggplot2 including the data sets that come with it? We have to load this. How do we load this? Either type library. Okay, I think I have an answer here. Yes, thank you, Trisha. That's correct. Library or require or click this. You can click that. When you click that, you notice that here, diba? Automatically, tina-type dito yung library ggplot2. So clicking this is tantamount to typing library ggplot2. Okay? So we have loaded ggplot2 already. Now let's try view diamonds. Okay? So if you type dia, and it will now appear, this one. So you can just press tab so that it will automatically load and then control enter. All right, we now have this. It will now print for us. It will now generate in a new window, in a new tab, the diamonds data set. 53,940 rows of observations and 10 variables. Okay, and notice so where is your diamonds? Okay, where is my diamonds here? Why doesn't it appear? All right, let me check. Data should have appeared because I already viewed it. Okay, control enter. Okay, there. First we have to load the diamonds data set data first, and then after that we use view. Okay. Now what happened? A while ago, I failed to tell you that it was here under values, but now it's here, data. Okay, so there's a difference between diamonds and your values. Your values are vectors, while on the other hand, diamonds is, we can know that by getting the structure. the structure of diamonds. Okay, its structure, control enter. There you go. So let's see. So let me rerun that. Control enter. All right. Still doesn't fit. So diamonds is a T-ball. Okay, T-ball is a type of a data frame, which is one of the data structures. Okay, in a while we're going to see what a data frame is. So this is a T-ball or a table data frame consisting of 53,940 rows of observations by 10 variables. And we discussed this last time. It also tells us the type of variable you have under this one. That is numerical, that is ordinal factor. Okay, remember the factor. It's a character variable, specifically a categorical variable. So if it's a categorical variable, we can use it for categorization. Then it can be called as a factor. And then if there's order, ranking, then it's an ordinal factor. Okay, so that's just a review of what we discussed last time. What I wanted to show you is that the data frames are situated or arranged separately from your vectors here. Okay, and when you view your data frame, it will generate like it's like a spreadsheet, diba ito? Okay, of the different values. But for a vector, it will not generate this type. So for example, if I go here, if I click, for example, G1. Okay, if I view G1, right, G1 here, view G1, okay, it will only return this. Okay, it will only return this. It will not generate a column of the different values. Okay, so let's move on. Okay, so logical vector class, we know that this object J, if we're concatenating false and true, this will return an error term because this is neither a character object, character data, nor a logical data, because false and true should be spelled out, all capital letters, or just the first letter capital. Okay, so if I run this, J, okay, error, object false is not found. But if I run this, okay, so we now have J here. It's a logical, it's a logical vector consisting of 5 elements: false, true, etc. And we know that this false true word can be F, can be just the first letter. Okay. Okay, any questions so far, class? Okay, no questions. All right, so let's proceed. Now we can perform operations on vectors. Okay, here we're creating a vector of do you have this, class? Do you have this code? Yes or no?
Yes, sir.
Okay. All right. So we have this object numbers, and then it's an integer vector because C 1 to 10. And then if you run this, all right. So as we know, this will be an integer vector. Okay. If you check in our environment, it's already here. Numbers, integer, 1 to 10. Okay. So let's create another object. Okay, let's create numbers 1. Numbers 1 is we're creating a numerical vector. We know that because it's identified here, it's listed. So if you run this, you'll have class numerical type of double. Let's run this, and as expected, these are your answers. Okay, so we now have numbers and numbers 1. We can actually do operations with your vector. numbers, the object numbers consist of integer from 1 to 10. We can add 2 to that. So you can now see that the numbers which we're printing here, it's 1 to 10 plus 2. We can also multiply numbers times the square root of 10. So each of the elements of your numbers will be multiplied by the square root of 10. Let's run this. You can see that it generated the 10 numbers, but multiplied by the square root of 10. And we can also add 2 vectors, okay, numbers plus numbers 1. So we expect it to be, okay, just adding both vectors, numbers and numbers plus 1. Okay. So you notice that these numbers are the same size. Now what happens if, let's create a number, like I'll call it number 3 or number 2. I'll call it number 2 or numbers 2. Okay, and let's assign it C, okay, or 1 to 6. Okay, so we have here a vector 1 to 6, and then let's add numbers plus numbers 2. Okay, can we add numbers and numbers 2? Numbers 2, all right, it's an integer vector. It has 6 elements, but numbers has 10 elements. Now let's just use numbers 1. Numbers 1 has 10, the length is 10. Numbers 2 has a length of 6. If we add this, okay, we will be getting a warning. It says here, warning, longer object is not a multiple of the shorter object length. Numbers 1 has a length of 10. Numbers 2 has a length of 6. Okay, why don't we create, for example, let me create an object called num, and let's run this. Let's assign num, wala pa naman tayong num dito, to numbers 1 plus numbers 2, control enter. So although we have this object, okay, num, but it tells us longer object length is not a multiple of the shorter object length. Okay, let's print num. Okay, so it executed the command. We have this num. However, what happened here? Because numbers 2 has 6 elements and numbers 1 has 10 elements. Sorry, numbers 2 has only 6 elements. So what happened? It added numbers 1 and numbers 2 for the first 6 elements. All right. So 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, plus 5 plus 5, 6 plus 6. And then when we reach the 7th element, numbers 1, the 7th element is 7. It went back to 1 for numbers 2. It went back to 1. So now we have 7 plus 1, 8 plus 2, 9 plus 3, until 10 plus 4. That's why we're getting here 8, 10, 12, 14. Okay? So there was a warning, but still R ran that code and generated the object that we wanted. Okay? But you notice from 12, it went back to 8 because for numbers 2, it went back to 1. It would have been different if this was 5. Let me make this 5. Okay. Yeah. Okay. Let's run this. Let me run first numbers 2. Okay, so it's 1, 2, 3, 4, 5. And then I'll add numbers 1, which has 10 elements, numbers 2, which has 5 elements. Okay, so no problem. Print. Okay, what happened? This has 5 elements, this has 10 elements. So since 10 is a perfect multiple of 5, okay, so it just went back to 1, and since there was exactly it was 5 is 10 is a multiple of 5, or is it baliktad, no? 5 is a multiple of 10. Okay, so perfect multiple, 5 times 2. So it just went back to adding 6, 7, 8, 9, 10 to 1, 2, 3, 4, 5. Okay, I hope you get what I mean. The other one, we had a warning sign that 6 is not a multiple of 10. So let me once again run this. Okay, and add, and you can see the warning. Longer object length is not a multiple of the shorter object length. Okay. Any questions about that, class?
Sir, can you scroll up?
Scroll up, okay.
Thank you, sir.
Okay, so there. Any other questions? All right. So now sequence. Sequence is also a good function. Okay, I leave you guys to look at. Okay, tinan na rin natin. Question mark, help, sequence. Okay, here you go. Sequence. Let's click this, Control Enter, and then it will go. It will give us a. This is also a generator of numbers. Okay, but not necessarily not necessarily random. Okay, because here it comes from the base package. That's why we don't need to load this. This will come preloaded with R. Okay, so what does it do? It generates a sequence of numbers from one number to another number, and either you can specify by how much will be the increment, or you can specify how much should be the final number. Okay, so better to use an example to explain this. Okay, so let's do this. Okay, so let's copy this. Okay, let's use this. Control C, and let me copy that to. You may copy that in your source window. I'll just copy it in my console. All right, the command here is sequence 0 to 1, length that out 11. So it's telling us that from 0, beginning with 0 up to 1, generate 11 numbers. So what it will do is equally generate 11 numbers from 0 to 1. So let's run this. Okay. So from 0 up to 1, how many numbers were generated? 11. And notice that it's equidistant from each other. Okay, so it was incrementing by 0.1. Okay, remember what's 10 here? 10 means that this is the 10th element. Therefore, 1 here is the 11th element. So this is correct. It generated a number from 0 up to 1 with the length. The length of this sequence is 11. Okay, let's have another example here. Let's take a look at this. This one. Control C, Control V. So here we're asking R to generate a sequence of numbers from 1.575 to 5.125, and then incrementing by 0.05. So what it will do is add on 0.05, 0.05, 0.05 until it reaches 5.125. Here we're not defining the length of the object to be created. What we're defining is the increment. So if we run this, okay. So it started with 1.575 and it ended to 5.125, incrementing by 0.06. Okay. All right. So what if we wanted to increment by 0.08, for example? Okay, which is not exact, right? It's not 0.05. Let's see what happens. Okay. So notice that it did not generate the last number, 5.125. Because why did it not? Why did it only end to 5.095? The last number, if we still add 0.08 to it, plus 0.08, oops. Okay, 0.08, Control Enter. Okay, it will, what happened? It will go beyond the 5.125. Okay, so this was the stricter rule that it followed. Okay, it ended at 5.0925. It did not follow this because it should be equally spaced by 0.08. If I add 0.08 here, it will become 5.175, which is beyond 5.125. So these are just boundaries. Okay, you cannot exceed 5.125. All right. Any questions about sequence, class? Okay, let's do this. Okay, I don't know if I gave this to you. Did I give this to you, class? This code chunk? Yes or no, please? Do you have this? Kindly check if you have it, class. Okay, no. All right. I'll just so that we can move faster. Just copy the code inside a code chunk so that we save on time. All right. For this example, just the same. We started 1 and then end in 3 and then increment by 0.2. Actually, we don't need this. It will automatically print even without the parentheses. Why? Because we're not assigning a name to this. We're not assigning an object to this. But if I do assign the name of an object, then we will need to put it in parentheses to have it printed. So sequence from 1 to 3 by 0.2. Okay, so we have this 1 incrementing by 0.2 until 3. And then here we're using length out, which means what we want is a length of 4. Okay, so R will make sure that from 1 to 5 we have 4 data, 4 observations, and that they're equidistant from each other. Let's run this. All right. If you can see, the difference between 2.333 and 1 is 1.333. The difference between this number and this number is 1.333. The difference between 5 and 3.67 is 1.333. So they're all equidistant. So when you're using this length out, R will generate a sequence of numbers which are equidistant from each other. Okay. All right, I'll give you a few seconds to run. And then kindly please chat yes if you were able to run the code chunk. Okay, thank you. Okay, waiting for the others to also chat. Okay, good. Thank you. All right. Okay, so for this, okay, let me also chat this, put this in chat so that you can copy it in the interest of time. Okay. So we can modify a vector using the assignment operator. All right. So here we're generating an object called Q, and it's a vector of numbers from numeric vector from -3 up to 2. So let's run this and have Q printed. Okay, so that's our vector. And we can see here our vector numeric from -3, -2 until 2. So if I want to replace, remember this, the brackets, that's for subsetting. If I type here Q and then bracket 2, let me just type here Q2, it will give us -2. Why is that so? Because if you take a look at Q, the second element here is -2. Okay, now if I want to replace the second element, so I will subset it. Q, second element, will be 0. Okay, so here we're replacing a particular element in your Q object by this value 0. And let's print it. Okay, so we now can see that it's -3. The -2 became 0. -1, 0, 1, 2. Okay, we replaced it by the assignment operator and then subsetting. Okay, let me pause for a while and ask you if we're okay so far. Please chat yes. If our speed, the lesson so far are okay. Am I going too fast? Are there some things here that you don't understand? Okay. How about the rest? Kanina 23 tayo, ngayon 20 na lang. May nag-disappear na tatlo. Okay, thank you so much. Although hindi pa rin tayo nakaka 100% participation rate. No? Okay, and the next example. Okay, good, thank you. All right, in the next example, we are creating Q, okay, but this time we're assigning the word null. So what will happen? Okay, what happens here is that if I assign the object Q, remember we have this object Q, right? It's a numeric vector. These are the elements. If I assign Q with null, control enter, what happens? It has now become null. And in the object here, Q, it's null, which means this is not non-existent anymore because it's null, it's zero, it's nothing, right? So another way to delete your object, for example, aside from assigning null to it, okay, let's take a look at some more objects here. Okay, for example, this M. Okay, if I want to remove M, we can make use of the function Rm. Okay, Rm means remove. Okay, so take note, we have M here, but if I Rm M, remove M, all right, control enter, what happened? M is gone. If I have M printed, M, control enter, okay, object M not found because we deleted it, we removed it. Okay, so Rm, the Rm function, which means remove, will remove any object that we generated here. Okay, it can remove even data frames. Okay, Rm diamonds. Let's see what happens if we remove diamonds. Control enter. There, see, diamond has already been removed from our object. Okay, if we take, for example, the mean of diamonds, carat, right? Carat. Let's see what happens if we can get the mean. Okay. Nakuha pa niya, no? Bakit? Okay, Y plus. Wala na siya sa objects natin dito. But why are we still able to get the mean of diamonds carat? Anyone? Why is it that despite, okay, let's see. Let's go view, not view. Head diamonds. It still gives us, right? It still gives us the head, the first 6 elements. Now, why is that so, class? Eh, di ba wala na dito sa ano natin? Wala na dito sa object natin yung data ng diamonds. Why do you think can we still compute for the mean and even the head of diamonds? Okay, you're correct. Emil is correct because Emil said that diamonds is part of the ggplot2 package. Okay, and we already loaded ggplot2. So everything in ggplot2 we can access. Okay, so this is an example. But let's see. Let's go here, class. Okay, I'm going to copy this. Okay, we're running out of time. Medyo na dun sa kabilang section natapos na namin kung list at saka nakapagsimula na kami. We already started with data frames. Okay, let me just copy this, Control C. just to illustrate yung Rn. And what I'm going to do, class, is that I'm going to also post the video I had there. Maybe you should watch that, at least yung portion na we discuss the list, so that we will be at par with the other section. I don't want us to be behind. Good thing we have a recording of that, so you can just view that. And next meeting, just a quick review of list. Okay, so let me chat this put this in the chat box. Okay. So just copy this first here. Maybe just copy this in the sa console na lang muna, no? Okay, sa console. Okay, let's run this one by one. First, we're creating this object n. Yan. Naran na nila. Hindi pa pwedeng line by line dito. Okay, so we have here, we're creating this object n, which is a vector of numerical vector. Yan, no? N, there's n. N is 2, 3, 5. And then we have S, vector of characters A, A, B, B, C, C. And then B, vector of logical vector, true, false, true. So here, logical vector, true, false, true. Okay, then the last one, which I shared with you, we're creating this object df, and df is equal to data.frame. All right? And then we're specifying that the data.frame consists of n, s, and b. So when we printed this, take a look. This one, it's n, s, b. And if we take a look at the structure of df, okay, because df is already existing, here it's in the data section, right? So in fact, if I click this, because it's a data frame, it will show us this tab to this data frame here. Okay, and if I take a look at the structure of data frame, okay, df, it's a data frame, 3 observations of 3 variables. We have 1 numeric, character, and logical. Now, if I remove data frame rm df, okay, rm df, I remove it. Okay, what happened? Dm is no longer there. Okay, and if I get the structure of df, okay, what do you have here? Okay, it gives us a different thing because df is a function. Okay, and it does not give us the data frame, the structure of data frame, right? So it gives us a different answer because df apparently is a function. Okay, and these are the parameters of that function. Okay, so it did not give us the structure of df. In fact, if you get the mean of df dollar, let's see, the n here, the numerical vector, mean of df dollar n, okay, it will give us an error term. Why? Because there is no object called df. Okay, it's non-existent. All right. So, okay, so let me stop there. I'm sorry, I went above time a bit. All right, let me stop recording.